Hey everybody, today we are going to talk about molarity. So we're going to be doing a bunch of math problems. You might want a calculator for this one. Alright, we've already talked about the fact that concentration, we care about concentration, about dilute versus concentrated solutions. Well, in a liquid we call it molarity, so that's the term we need to know. Right? And molarity is the concentration of a solute in a solution expressed as the number of moles. That's important. Number of moles of solute dissolved in 1 liter of solution. We abbreviate this as M, and you'll notice molarity has the word mole in it. So that's one way to remember this. It's the number of moles of solute dissolved in 1 liter of solution. So this is the formula that we use. All right, we're going to see that a lot. Molarity, moles of solute, liters of solution. Okay, so what's the molarity of a solution if we have 2 moles of sodium nitrate dissolved in 1 liter of solution? Well, because it's just moles per liter, we don't have to worry about what it is. We can just see that we have 2 moles divided by 1 liter. So our molarity, which is abbreviated M, is going to be equal to 2. It's that simple. Alright, now what's the molarity of a solution if we have 2 moles of sodium nitrate dissolved in 2 liters of solution? Can you do that one? Well, it's still pretty easy. We have 2 moles of our solute of sodium nitrate dissolved in 2 liters of solution. 2 divided by 2 is equal to 1, so it's a 1 molar solution. Alright, this one's a little bit more complicated. Can you do that one? Sure, that's 2 moles of sodium nitrate divided by 8 liters. So that's going to be 2/8 is 0.25 molar. Right, go ahead and pause the video, do this one. Alright, well that one was a little bit more complicated because we're starting out with 0.4 moles, but you're about to write 800 liters down here, but it's not, it's milliliters. Right? And so you have to remember that there are 1,000 milliliters in 1 liter, so this is 0.800 liters. Now guys, I don't bother doing this math every time. I just look at it and I say, I know that there are 1,000 milliliters in a liter, so I just immediately write that down as 0.800, so this is going to be 0.5 molar. Right? Because remember, this is moles per liter, and so your units down here need to be liters, not milliliters, so be careful about that. Okay. Alright, now this is the first time we're talking about grams. Now you can't just divide this because now we have grams of sodium nitrate. So the only way to do, we have to get moles and liters, right? Now we look at the 0.500 liters, so this part up here is going to be 0.500. The question is, what's our moles? That's what we have to figure out. And we're given grams. So we have 21.25 grams of sodium nitrate. So you have to be able to figure out that sodium nitrate is NaNO3. And then what I have to do is I have to calculate the molar mass of sodium nitrate. Well, sodium is 22.99 and nitrogen is 14.007, and there are 3 oxygens, so that's 48. I add all of those together and I get 84.997 grams of sodium nitrate in 1 mole of sodium nitrate. Right? So when I do that math, I come up with 0.2500 moles of sodium nitrate. That's the number that's going to have to go up on top. So 0.2500 divided by 0.500 is equal to, well, clearly that is 1/2. So it's 0.5 molar. Alright, so here's one for you to try. See if you can do this one. What's the molarity of a solution if we have 27.75 grams of calcium chloride and 250 mils of solution? Give it a shot. Pause the video. You do it. Alright, 250 milliliters is 0.250 liters, and 27 points, actually it's 0.25 liters, And 27.75 grams of calcium chloride. Well, calcium chloride is CaCl2. And I have to figure out that calcium chloride is 110.986 grams per mole. You should be able to do that. So I have 27.75 grams of calcium chloride. And I had to convert from grams of calcium chloride to moles of calcium chloride. And that is going to be 1 mole of calcium chloride is 110.986 grams. So I do the math, and that gives me, let's see, hello. Sorry, had to find it because I've already done a 0.2500 moles. Well, if I have 0.2500 moles and I divide it by 0.25 liters, guess what that gives me? That gives me 1 molar. That gives me a 1 molar solution. So that one was really easy. All right, try another one. Go ahead and pause the video. Try that on your own. All right, well, my liters are already 0.1, so I don't have to worry about that. That's easy. The units are right. But I have to take 10.0 grams of potassium nitrate, that's KNO3, and I have to divide that by the mass of KNO3. The mass of KNO3 is 101.107 grams in 1 mole. And I do that math, and I get 0.0989 moles. And I have to divide that by, to get my molarity, which is 0.100. So that's really close to 1, which is actually 0.989 molar. All right, let's try the next one. Or you should try the next one. Give it a shot, pause the video, make sure you can do this. And you say, well, why is he making me do this? Well, frankly, because I'm putting words in here that I want to make sure that you can come up with the proper formulas for. Potassium chlorate is KClO3. So you should be able to figure that out, what the formula is, and as a result, you should be able to figure out that it weighs 122.553 grams per mole. 250 milliliters is 0.25 liters. So I have 0.102 moles. I'm sorry, I didn't do that yet. 12.5 grams of KClO3 divided by 122.553 grams in 1 mole of KClO3. That's what gives me the 0.102 moles of KClO3. So now I do the division. 0.102 moles divided by 0.25 liters, and that's going to give me 0.41 molar. All right. How many moles of sodium chloride are in 125 mils at a 0.45? Ooh, different question. How many moles? I'm not asking for molarity this time. How do we do that? Well, it's actually pretty easy. If we look at our equation up here, we have molarity equals moles of solute divided by liters of solution. So we just want to solve for moles of solute. So that's simply molarity times liters of solution. So moles is equal to molarity times our volume, which is in liters. So let's see, what do we have? We have our molarity, which is 0.045 molar. And our liters up, well, we have 125 milliliters. That's 0.125 liters. So I have to multiply by 0.125. Right? And when I do that, I get 0.0056 moles of NaCl. That was easy. All right. And it looked scary at first. All right. But we can just modify this. If I'd asked you for liters, you could have done something with that too. All right. So look at this one. How many grams of sodium chloride are in 250 mils of a 0.62 molar solution? Can you figure that out? Well, did you pause the video? Try it. Come on, guys. All right. Well, you can't get to moles, but you can't get to grams, but you can get to moles. So let's do that first. So moles is equal to molarity times liters. So my molarity is 0.062 and my liters are 0.250. Right? If I multiply those two numbers together, I get 0.0155 moles. Now I'm trying to get to grams of sodium chloride, so I have to figure out how much sodium chloride weighs. So 0.0155 moles of NaCl, and I have to get rid of moles of NaCl and go to grams of NaCl. And by now I should be able to figure out that 1 mole of NaCl is 58.443 grams. And this will give me 0.91 grams of NaCl. All right. Now, here's a problem where I'm supposed to be preparing a stock solution of sodium nitrate. All right, so how in the world would I do this? This is something that would be very, very common for me in the lab, is to say, well, we need a particular concentration of a solution that we're going to be using in the lab. Right? So, how in fact would I do this? Well, I have to create a 4 molar stock solution, but I only have to create 500 milliliters. So if I remember that my molarity is equal to moles divided by liters, well, I know liters and I know my molarity, so I need moles here. Right? So that would be moles is equal to my molarity times my liters, which means my molarity is 4 and my liters are 0.500. Right? So that's going to give me 2 moles. So I need 2 moles of sodium nitrate to be able to make this happen. And sodium nitrate is NaNO3. Right? So I have to figure out how much it weighs. Well, 1 mole of sodium nitrate weighs 84.997 grams per mole. Well, I need 2 moles, and 1 mole weighs 84.997 grams. So I multiply that out, and I get 169.994 grams of sodium nitrate in 500 milliliters of solution to make a 4 molar stock solution. So there's a way where you would actually use this information that we're actually doing. Okay, and guys, I just did this last week with sodium hydroxide and with copper sulfate. So I've done it recently. All right, how do you actually prepare a stock solution? Well, you can either use a solid down here. You'll notice that we put some solid down here, or you could put a liquid. Either way, it depends on what you're doing. All right, and then you pour your water in, and in fact, you're going to pour your water right up to this line right here. This might, let's say that this was a 500 milliliter volumetric flask. You're filling it so that the bottom of the meniscus hits that line right there, and that's exactly 500 milliliters, or whatever it says on the front of the volumetric flask. Okay, so that's done. Go give it a shot. Go to your worksheet, and if you have questions, please let us know. We'll be more than happy to help you. Okay, have a great day. Bye bye.